Skills in the environment. This is video 3. In this video I'm going to be looking at wave formation and rip currents. This one is a slightly shorter video than the two videos that preceded this, the video on tides and the video on ocean currents. All of these videos and quizzes that go with them can be found at my website www.goprocaribbean.com.
It might surprise you to hear the energy in a wave actually comes from the wind. More than 70% of the Earth's surface is covered in water. And when wind blows over the surface of that water, it causes friction. That pushes some parts of the water down, and in turn other areas are pushed up. These areas of water then start spinning in a circle, and that's the beginning of a wave. And the more wind, the bigger those waves can get. But it's only when waves get closer to land that the spinning effect bobs us up and down on the surface, and eventually causes waves to crash on the sand.
Waves are primarily caused by the wind, is what we now know. Ocean swell becomes a wave when the water below it gets shallower, since the circular motion of the wave is being disrupted. What you want to do is you really want to think about that circle that we saw inside the wave in the video, and see that the circle actually the bottom of the circle went below the wave, and that is when a wave breaks, is when the water below the wave is only 1.3 times its height. It's at that point that that bottom third of the circle that we saw would be being interrupted by the land. We'll look at that video again and look at that circle and see how much of the bottom of the circle is actually below the wave height, below the water level, and you'll see that it's approximately 1/3 of the bottom of the circle, which is why a wave breaks when the water below it starts getting shallower, such as when approaching the shore. If you imagine this wave approaching the shore, when the bottom half of that circle starts touching the bottom, the wave loses stability and starts to break. Rip currents.
You might have heard them referred to as undertow or riptides, but these ocean phenomena are actually rip currents. Rip currents are narrow currents in the surf zone that move quickly away from shore. A typical rip current ranges from 50 to 100 feet wide and can extend 100 yards or more offshore. It can reach speeds of over 5 miles per hour. That's faster than an Olympic swimmer. That makes them dangerous and potentially deadly, and scientists want to learn more about them so we can better forecast when and where they will form and keep beachgoers safe. Here's what we know. Waves don't have to be huge for a rip current to form. 2 or 3 feet are all it takes. And the weather doesn't have to be bad for a rip current to emerge. They often occur in the nice days after a storm. They're usually strongest near low tide, but can form at any time. Rip currents often form where sandbars are near the shore. They occur at breaks or channels in the bar. They're often difficult to see, but you can spot them in areas where waves aren't breaking, or where there's foam, seaweed, or discolored water being pulled offshore. It's easier to see a rip current from higher up, such as from the beach access over dunes or a lifeguard's tower.
Rip currents are formed because the water is brought into the beach as waves, and then it needs to get back out to sea. So what happens is the water runs sideways, parallel to the beach, digging sand out as it goes, forming a feeder rip. It depends on the structure of the beach, but at some point it'll turn out to sea, forming a deep channel as it flows out, eroding sand with it as it goes.
This diagram, I think, is very helpful in understanding rip currents. What you have to imagine is waves breaking over this sandbar, or instead of a sandbar, in fact here in Roatan, it would be our fringing reef. So when we have waves large enough to be pushing large amounts of water over the top of the sandbar or fringing reef, all that water that is now collecting in the inner lagoon inside the sandbar somehow needs to escape. You're not going to see the water level rising on the beach, so that water is going to escape somewhere. Where does it escape? Where it finds a channel, where it finds a gap in the sandbar or a gap in the fringing reef. We have some very popular dive sites, Blue Channel and Spooky Channel here in Roatan, and those are, as the name suggests, channels. So when you are diving in those channels, paying attention to the waves and whether there's a reasonable amount of wave action breaking over the top of the reef will be a very important step in deciding an appropriate day to dive sites such as that, because on the days when there's a reasonable amount of wave action coming in and breaking over that fringing reef, you can expect there to be a strong current passing out seaward through that channel. If it's also at the same time as the tide is going out, we're moving from high tide to low tide, you can expect an even stronger current. Rip currents can be recognized as a line of turbid or foamy water, or turbid and foamy water, moving seaward. That's quite a good point to maybe write down in your notes. Rip currents, a line of turbid, foamy water moving seaward. That's the end of the Skills in the Environment video on waves and rip currents. Please, if you are finding these videos useful, of course hit the like button and subscribe to my YouTube channel, but even more helpful is to post in any blogs you're writing or any forums or on your website. Post a link to my website, www.goprocaribbean.com. That is where the people you are sharing this information with will be able to find the videos in the manner that allows them to watch them in the order they're intended to be watched in, along with useful notes and then the quizzes they can do to cement their knowledge. Thanks for watching.